This is another project using the dataset by iCoolhunt. So 2 projects on the same dataset. Sorry for the low contrast of the projector. It's my fault, of course, not the guys. Who start? Meltem, you start.
Hi, everybody. So we're also using the iCoolhunt dataset, so we won't really talk about what the dataset is. You already know. Yes, ontology. If you go to the first one. So we actually had this motivation. We realized yesterday that people kind of mistook our whole goal. So our idea wasn't to define coolness, but it was actually to have a second higher level clustering for, the idea of iCoolhunt. So we were thinking if we can get the tags already that's within the data, and then also introduce this low level data, which is the color space, but take it to this higher semantic space by, you will see eventually, and then basically just support the end users in order to explore this iCoolhunt data. So our goal basically, again, like I said, is to organize the praise and then provide users with another way of clustering. So for example, right now they can search by tags or they have trend boxes. So this could be a third approach where they can search by semantic vocabulary, let's say. So for this, what we did is, this is our approach. So first is we created an ontology based on the color psychology. So for color psychology, what I mean is, for example, if you have the color red, it means power, etc. So you will see eventually more about this. So first we have to create the ontology. And then second is we aggregate this data with the hunter-defined tags, which are already in the data. And then the third one is actually provide these new clusters based on these new unified features.
So the data from iCoolhunt, the raw data that we got, that was a set of JSON dumps, as you already know. We used only one, which is describing the praise. And in that data, each object is the prey with the relevant fields. You can see an example. It's like description, tags, and basically what we needed from here is the tags and the ID so that we could scrape the images. And then first thing that we did the standard TF-IDF. We used TF-IDF approach to weight the tags, and then we kind of tried to see if we get reasonable topics. And I hope you can read. That makes sense, at least for us. Then the next thing that we did was the image processing. We kept it simple. We decided to take only, we decided to look only at the color. We took 10 most dominant colors in the image, and we worked in the HSL space because it's more natural, like that's hue, saturation, and lightness. It was easier to use this space in order to get to the semantics. So this is this color psychology that we used, the terms of color psychology, the power with different levels of power, passion, energy, joy, ease, light, temperature, and purity, and for each one different levels of that. And this is how we converted the color to the words.
So for example, one of the semantics we had was temperature. So we kind of broke it down to warm, subtle, cool, and cold. And here, for example, you can actually see we're actually looking at its hue, and it's also saturation, and its lightness. So we have these certain ranges. If we had more time, we would be tweaking them more, but this is just like a really standard approach. And then, for example, for power, we have vigorous and strong. And again, it's based on how brightly red they are or how dimly red they are. So it's just tweaking around with the HSL space and then deciding what color can actually go into which semantic attribute. This is just a really simple check energy function that we had, for example. So we had this type of functions for every semantic attribute we had. We would just send in the images, and then they would come back with this just simple dictionary where we would have the counts of, you know, how much explosive or exciting or energetic they are, if they are. And then the whole machine learning part.
So we already had the feature set for tags, and next thing that we did, we just stacked two matrices together, the TF-IDF, and this color semantics output that we got after processing the images. We tried like this. This was the first try, and it turned out that it was the best, not out of many trials, we have to admit, because we didn't have time. It was more about doing different things and finishing, like coming to the end, rather than you know, going deep into the machine learning and optimizing it and validating things. You'll see in the end that that's the criticism of our own job, that it's not validated. It's just there. You can do that. So this is an example of a cluster that we got based on this approach. You can see, for example, in the tags, you see yellow, light, colors, cocktails, illustrations, and in the color semantics, the most dominant ones were explosive, warm, cold, which is explosive and warm is what makes sense. And the scores you see, the first one is much bigger than the others, and it corresponds to this explosiveness. So this cluster was more color, yes, color than that. Next thing that we did, again, that was not something very deep and thoroughly thought thing, but when we got the clusters, we looked at what we have, the tags and the color semantics, and we gave names to them. And the idea was that we have like the rightmost word in each line is the main category, and lefter you go or deeper you go in the hierarchy, more or less. Like sensitive original means that we want to see this cluster in the original set of yeah.
Places where you have, I can't really see it now, but we had examples. So it's not a deep hierarchy. It's just original, smart, aesthetic, and stimulating are the top branches. And then down below, there's no hierarchy, basically. And I mean, yeah.
So for our demonstration, which is coming, we needed the data, which in the end was the raw data, and to which we appended the scores of each prey in each cluster, and the colors, basically, the processed 10 colors, the dominant colors. These are just the tools that we used for our goals, for purposes, and then it's the demonstration time.
Exploration view part is based on clusters and filtering them. The second thing is the prey view, which you will see more information about the semantic scores for each prey. And then the third place will be the prediction area, where you can actually make predictions for new incoming preys. So here at the top, we have the semantic attributes. It's like all original, aesthetic, smart, stimulating. And then down we have all the images that we collected from iCoolhunt's website. And when you, for example, hover over an image, you get to see the 3 most dominant colors within that image, and also the tags or the description based on whatever information they've sent. So this is more of the exploration site of this whole application. You can just go through these images, look at their colors and their tags, and then if you click on a certain... So here, for example, we define these images more aesthetic than smart, original, or stimulating. I mean, it's not saying that they aren't, but it's just they're more of that kind. So this is stimulating and dark, I think? Okay. So basically here we're saying that they are kind of, and by stimulating we meant provocative, but then we couldn't really use the word because looking at the images, they didn't really fit all the time. And they're dark because of, the colors and the hue space, more purplish, more, bluish, so that we said dark. And if we click on an image here, for example, you can see that this image is defined to be aesthetic and provocative, basically, more than being original or smart. And you can also see its main colors, like the top 10, not the 10, but the most dominant colors. And you see the tags and also where the image was taken from. And again, for example, for this one, it's just completely original based on colors, and it kind of works, at least for us. And this is a nice predictionary. And I'll click and...
Yeah. We want to think that it works or it can work in the end. And the idea... Yeah, so the idea behind this is that, for example, the user creates a new prey. It's an image with tags, and the idea is that having the praise, on the right side you see the new praise, let's say. Here it's just hard-coded for demonstration. And the user can see where this image fits, just based on the colors and the tags. And we see that it's aesthetic. Or with the next one, we see that it's stimulating, or we see the combination. And what you see in this graph is just the center of masses between these 4 points, and the masses are basically the score that you get for this prey. So yeah, what we did, you saw that, and what we didn't, what is missing, as I said, that's machine learning part, it's not even validated. The semantics, that's kind of, yeah, it needs improvement, a lot of improvement, because in the end we realized that we don't have time to think about that, but that's exactly what it needs, time and consideration. Then the third point, the semantics overview, is about the visualization, about the application, because initially we had an idea that first you go, you see an overview of this highest level vocabulary, like in our case it was smart, original, stimulating, and for that you see some overview, statistics, how many praise, how popular this topic, this word is now, or this kind of things. We really wanted to do that, but didn't manage to fit into the time. And yes, the last point. That's something. It's a disclaimer that the prediction part right here, there's no backend. It's all hard-coded. We just read the JSON object of that prey, and we showed the scores in this graph. But hopefully you see the idea. It's that there is the machine learning algorithm running in the backend, that it works for a new prey. Yes, and if you have questions. At least in our case, it wouldn't take long having the machine kind of trained and uploading the image, like getting 10 dominant colors. That takes like a second or two, and yeah.
They had more complex analysis, but in our case, it was just k-means clustering on the HSL space, and that's it. And it took around, like, I don't know, a second per image based on, where you're running it. So, and assuming that we've already done the machine learning, we already have the model trained and everything, we just do a prediction. So I don't think it would be that hard, but again, I mean, I have no idea. Yeah, great.
So